Okay, for problem 1, let's talk about the integral test. Okay, so let's say I give you a series. Okay, so if the an is both decreasing and always positive when n is greater or equal to a number, for example, c, right? Then this series and the integral of the corresponding fitting function, right? They're either both convergent or both divergent. Okay, so you can see this integral test. It's a test for some special type of series. Okay, first this series must satisfy that it's a decreasing and positive series when n is greater or equal to c. Okay, what does that mean? That means you don't have to be decreasing and positive from the first, right, from A1. You don't have to do that. For example, starting from A6, now this series is decreasing but always positive. It's also fine, right? You can also apply the integral test. Okay, so to apply the integral test, you have to check whether the series is so you have to check whether the series is decreasing and positive, right? For the first one, this is very easy to check, right? Your an is 1 over 3n minus 1 to the power 4. This is always positive, right? This is always positive because, right, when n is 1, this is a positive number. When n is 2, it's a positive number. So anyways, the bottom is always a positive number. The fraction is always a positive number, right? And here, you don't have to prove. You can already say that an is decreasing, right? Because when n is greater and greater, this bottom is going to be larger and larger, right? So the total fraction is going to be smaller and smaller. Okay, so you've already checked that an is positive and decreasing. So now you can use the integral test. Okay, so now all you need to do is to solve the integration of its corresponding function. So what is its fitting function? It's just change n to x, right? That's its fitting function. So now you just need to solve this, right? You just need to get this integral to see whether this integral is convergent or divergent, right? You just need to get whether this integral is convergent or divergent. So here you can use a substitution method. You can let u to be 3x minus 1. Then du over dx, it is just 3. Okay, so u is 3x minus 1. So here x is 1. U is 3x minus 1. It is 3 times 1 minus 1. It is 2. Okay, infinity is still infinity. It's 1 over u to the power 4. Okay, and then du. So du is, right, by the way, dx is 1 over 3 du. Okay, so you just write down 1 over 3 du here. Okay, so it's 1 over 3, the integration from 2 to infinity, u to the power of negative 4. Okay, then what is the integral? It is u to the power of negative 3 times, right, times negative 1 over 3 from 2 to infinity, okay, times 1 over 3. So we put the constant together, it's negative 1 over 9, okay, then it is, right, u to the power of negative 3. Do the substitution from 2 to infinity. Okay, when it's infinity, you can see infinity to the power of negative 3, that would be 0. Okay, then minus 2 to the power of negative 3. So you do the calculation, it is actually 1 over 72. Okay. So this is 1 over 72. This is a real number. It means what? Right? It means this improper integral is convergent. Okay? Because the integral is a number. Then just now we said if an is decreasing but always positive, then the series and the improper integral, they are either both convergent or both divergent. Right? So you already know the integral is convergent. Right? So the series is also convergent. Okay? So the series is also convergent. So that's the logic of the integral test. Okay, that's the logic of the integral test. So let's do part B. Okay, part B. It is from 2 to infinity n to the power 3 over n to the power 4 plus 4. Okay, so first, this function, it is always positive, right? That's easy to prove because this is always positive when n is 2, 3, 4, 5, etc., etc. This is always positive. Okay, but how do we prove this is a decreasing function? So to prove it's decreasing, we have to write down its fitting function and study its derivative. Right? A function is decreasing if and only if its derivative is smaller than 0. Right? A function is decreasing if and only if its derivative is smaller than 0. So we can just get fx derivative, then it is a bottom square. Okay, so here's the trick is you don't have to, open the square. Just leave it like that. And the top's derivative times bottom plus top minus top times the bottom's derivative. Okay, so it is actually 3 minus 4x to the power 6, so it's 12x squared minus x to the power 6 over this positive value. Okay, so it's actually x squared, right? 12 minus x to the power 4 over this positive value. So now you can see this is positive, right? This is always positive when x is greater than 1. So for this part, when x is 1, right, 12 minus 1, it's still positive. When x is 2, 12 minus 2 to the power 4, this is already negative, right? And when x is larger and larger, this is always negative. So you can say this is smaller than 0 when x is greater or equal to 2. Okay, so that satisfies our definition here, right? The an is decreasing and positive when n is greater or equal to 2. Okay, so we can still use the integral test. Okay, so we can still use the integral test. This is obviously positive, and we have proved that. Okay, let me write it down here. So this an, right, it's obviously positive, right, when n is 1, 2, 3, 4, etc., etc., and decreasing when n is greater or equal to 2. Okay, so now you can study the integral from 2 to infinity of its fitting function. Okay, and they are both, right, this integral and this series are both convergent or both divergent. So we can just do the integration here. So here to do the integration, you can use the substitution method. You can call the bottom u, and du over dx. It is 4x to the power 3. Okay, so that's why 1 over 4 du is equal to x cubed dx. Okay, so here the integral is, so u is x to the power 4 plus 4, right? So now x is 2, u is 2 to the power 4 plus 4, which is 20, okay? Then here, I have x cubed times dx. That is 1 over 4 du. Okay, so 1 over u times 1 over 4 du. So that part is 1 over 4, right, ln u from 20 to infinity. Okay, so you can see it's ln infinity minus ln 20. So ln infinity minus ln 20 is obviously infinity, right? So the result is infinity. Okay, so the result is infinity. That means this improper integration, it is convergent. Okay, that means this is divergent, okay, because the result is infinity. This is divergent. So the series must also be divergent as well. Okay, so the series must also be divergent. All right. So problems part C. Okay, part C, the series is n times e to the power of negative n squared. Okay, so again, obviously this is positive, right? All the terms are positive because e to the power of anything, it's always positive, right? N, when n is 1, 2, 3, 4, etc., n is positive. Okay, so we only need to worry about whether this is a decreasing function or not. So what do we do? Okay, we find out its derivative. So what do? We find out its derivative. So its derivative, it is u's derivatives times v plus u times v's derivative. Okay, so it is 1 minus 2x squared times e to the power of negative x squared. All right. So again, this part, e to the power of anything, it's always positive. You don't need to care. And this part, as you can see, when x is 1, it is already negative, right? It's already smaller than 0. When x is 2, it's smaller than 0 as well. So this part is always smaller than 0. So the derivative is smaller than 0 when x is greater or equal to 1. All right, so you can say that an, right, it is obviously positive and decreasing when n is greater or equal to 1. Right, so you can just calculate the integral of its fitting function. Okay. Again, you can do the substitution, use x squared, so du over dx is 2x. So half du is x 2x dx. So it is integration from 1 to infinity. So x times dx is half du, and here is e to the power of negative u. Right, du. Half du. Okay, so it's half e to the power of negative u. The integral is negative e to the power of negative u from 1 to infinity. Okay, then this part, so it's half, right? When this is infinity, e to the power of negative infinity is 0. Okay, minus e to the power of negative 1. So it's just positive e to the power of negative 1. Okay, this means what? This means this improper integral is convergent. Okay, this means its improper integral is convergent, and this means this series is also convergent. Okay.